This is on mathheals.com, where you can find more links to math YouTube videos and computer science. Let's take a look at a hypothesis test for a population proportion using the p-value approach by hand. Definition: when observed results are unlikely under the assumption the null hypothesis is true, we say the result is statistically significant and we reject the null hypothesis. Our steps: step 1, write down a shortened version of the claim. Don't get wordy on this, you want to keep it short and sweet. Step 2, come up with a null and alternate hypothesis. H0 always has equals part on it. Step 3, see if claim matches H0 or H1. We'll find our test statistic, Z0, that's equal to p hat. P hat is x over n, minus p0, and the p0 is number from your claim in decimal form, all over square root of p0 times 1 minus p0 divided by n. Then we're going to look up the z-score from step 4 in the standard normal distribution table and find the value from the table. And I'll just label that as VFT, value from table. Left tail, your p-value is the VFT. Right tail, your p-value is 1 minus the VFT. If you got two tails, first you check to see if the value from the table is less than or equal to 0.5. If it is, the p-value is 2 times VFT. And if it's greater than 0.5, then your p-value is 2 times 1 minus VFT. It took a little bit to get this right here in step 5. So I hope this is right now. Because at first I had it working, and then I ran across a problem that didn't work on. So I like a step-by-step approach that works 100% of the time. And that's my goal. Step 6. If p-value is less than alpha, reject H0. If p-value is greater than alpha, accept H0. Determine the claim based on step 3. And let's look at our first problem. This is according to ABC News in June 2012, 36% of people believe in UFOs in the United States. If a sample of 200 people find a 74 of them believe, so X is 74, and then it's 200. Test claim that percentage they believe in UFOs is greater now, at alpha is equal to 5%. So my claim is it's greater than 36%. There we go. Go back up to my steps. Step 1, write down a shortened version of the claim. Can't get any shorter than that. These are P's. Now it says come up with a null and alternate hypothesis. This is a greater than, so it's going to go here. If this is greater than, then this will be a less than or equal to. Now, the only symbols you can put on H1 are greater than, less than, and not equal to. Only symbols you can put on H0 are greater than or equal to, less than or equal to, or equal to. Now, I like to put the less than or equal to, greater than or equal to, and equal to because these are opposites of each other. So I think it makes more sense that way. But the current trend is to just put an equals on H0. So this is always equals. This can be any of these, but this one's always equal. Doesn't matter. It gives you the same answer. I just think students click better with them being exactly opposite. Plus, if you run across a problem where you need one of these symbols, then, because of how it's worded, then it's nice to have them available. Like if it said at least. Well, at least is greater than or equal to. So you'd have to reword it, so it's not at least. You'd have to flip it to the opposite in your wording before you could even do the claim process. Anyway, I'll quit whining. Let's see if claim matches H0 or H1. This is a greater than. We put the greater than on H1, so it matches H1. Now remember what this represents. I don't got that on this, but this is a right tail. Greater than on H1 means you have a right tail. Okay. It says find your test statistic. So Z0 is equal to p hat minus p naught over the square root of p naught times 1 minus p naught divided by n. Well, p hat would be x over n, so it would be 74 over 200 minus p naught, which is 0.36, over square root of 0.36 times 1 minus 0.36 divided by n, which is 200. Now, when you plug this in your calculator, you have to be careful. You have to put parentheses around the top. That's the trick to putting this one in. And, of course, I don't have my calculator, it looks like. So let me bring it up. Thought I had brought that up. Okay, so I'm going to do my beginning parentheses. 74 divided by 200 minus 0.36. Closing parentheses divided by second x squared for the square root, and then 0.36 times beginning parentheses 1 minus 0.36. Closing parentheses divided by 200. Let me double check that. Minus 0.36. Okay, enter. And we get 0.29. I want to take it 2 decimal places. The reason why is we're going to look it up in the back. Now we're going to find the VFT, which is the value from the table. So we're going to look up 0.29. Uh, 0.2 is over here, and the 9 is in a hundredths place. So we come over here. The intersection of 0.2 and 0.09 gives us 0.6141. Okay. Oh, I guess that was step 5. Look up the value from the standard normal distribution table. Now we got a right tail. And this says right tail, your p-value is 1 minus the value from the table. So our p-value is going to equal to 1 minus the value from the table. So I got 1 minus 0.6141. 1 minus 0.6141. And that gives us 0.3859. Okay, so our conclusion. It says that p-value is less than alpha. P-value is 0.3859. Alpha is 5. What was alpha? 5%? 0.05. So p-value is not less than it. It says if p-value is greater than alpha, accept h naught. Okay, so we're going to accept h naught, and h naught and h1 are opposites of each other, which means we'll reject h1. And if I come up here, I notice my claim matches h1, so whatever we say about h1 is what we say about our claim. So we'll reject our claim. Now again, about the word accept. Most books will have do not reject. Accept is a pretty strong word. I always use the example. I had a student who came in, and every chapter test in college algebra she'd get like 7 or 8%. Really low. You have to leave a lot of them blank. Really have no clue what you're doing to get that grade on one of my college algebra tests. Came in for the final exam. She got 100% on it. Got 25 out of 25. It's multiple choice and departmental final. I think she came in with the answers. I think somebody from a previous class gave her the answers and she came in with them. I think she cheated. I don't accept her innocence. I do not reject her innocence. Maybe she spent the last 3 weeks studying every minute and did excellent on it. Maybe she does better on multiple choice tests. So accept is a pretty strong word to say accept her innocence. This is the way with the claims. Accept is a pretty strong word. We instead say do not reject. Now, I find students click better if these are actually accept and reject, because they're easier to think of opposites of each other. Let's look at our next one. Okay, so according to the Chicago Tribune in 1990, 74% of teenagers believe in angels. If a sample of 500 teenagers show 410 believe in angels, so X is 410, and N is 500. Test a claim that the percentage is the same and alpha equals 10%. So alpha is 10%, and same. So same as 74%. Okay, step 1, write down a shortened version of the claim. We did that. Step 2, come up with a null and alternate hypothesis. We're dealing with population proportion. These are P's. Same as. That represents equals, which would go right here. And then this, if that's equals, this is not equal. Step 3, see if your claim matches H naught or H1. Well, same as is equals, so that matches H naught. Now, not equal to on H1 means two tails. So let's find Z naught, which is P hat minus P naught, over square root of P naught times 1 minus P naught, divided by N. P hat is X over N, so I got 410 over 500, minus P naught, that's the number off of our claim, which is 0.74, divided by square root of 0.74 times 1 minus 0.74, divided by N, which was 500. Okay, so let's see what we get. I'll do a beginning parentheses 410 divided by 500 minus 0.74, close parentheses divided by second x squared 0.74 times beginning parentheses 1 minus 0.74, closing parentheses divided by 500. Enter. And we get 4.08. Assuming I typed it in correctly. 410 minus... that looks right. Okay. So value from the table. .08. It doesn't go that high. It goes to 3.49. Now, see how these go from 0.9997, 0.9997, so forth? All I can really say is it's either going to be greater than or equal to 0.9998. So I'll go with equal. 0.99, 3 nines and an 8. That's our value from the table. Okay. Looked that up. For two tails, it says if your value from the table is greater than 0.5, which is greater than, the p-value is 2 times 1 minus that. So my p-value is going to be 2 times 1 minus 0.9998. Which is 2 times 1 minus 0.9998, which gives us 4 e to the negative 4. Okay, what does that mean? That's scientific notation. It means, and if I were to put a decimal place here, it'd be right here. It means move your decimal point 4 places to the left. So we'll have 0.1234. That would be our p-value. So our conclusion, if p-value is less than alpha, well, it's definitely less than alpha, it's a pretty small p-value. So it says reject H0. So we're going to reject H0, which means we'll accept H1. In this particular problem, though, our claim matches H0. So whatever we say about H0 is what we say about our claim. So we rejected H0, which means we'll reject our claim. Let's look at our next example. It says, according to Chicago Tribune, 1990, 50% of teenagers believe in ESP. If a sample of 400 teenagers showed 190 believe in ESP, test claim that percentage is different nowadays, that alpha is equal to 0.01. I always find it funny, people seem to believe more in what they can't see than what's in front of them. Like an atom, for example. I don't think we've ever seen an atom, but you probably find 100% of teenagers believe in that. But you get to religion, and you got what God's created all around you. They don't believe in that. So not all of them, but so our claim is different than. And then 50% is what believed before. Okay, so go to our steps. Step 1, write down a shortened version of the claim. We did that. Step 2, come up with a null and alternate hypothesis. Different than. Well, that would be a not equal to. Which, the only place you can put that is on H1. Remember where we can put these symbols. Then this has to be equal. 0.50 and 0.50. Step 3, see if a claim matches H0 or H1. Different than is not equal to, it matches H1. Well, it's a not equal on H1, so again it's two tails. Z0 is equal to P hat minus P0 over square root of P0 times 1 minus P0 all over n. P hat is x over n, so I got 190 over 400 minus P0, which is 0.50, divided by the square root of 0.50 times 1 minus 0.50 divided by n, which was 400. Okay, so let's see what that gives us. Remember, the key is put parentheses on top when you're plugging it in. So do a beginning parentheses, 190 divided by 400 minus 0.50, close parentheses, divided by second x squared, 0.50 times, beginning parentheses, 1 minus 0.50, close parentheses, divided by 400. Enter. -1. So the value from the table. -1, that'd be -1.0, which would be right here, and then the hundreds place is 0, 2. So it'd be 0.1587. So for two tails, it says if value from the table is less than 0.5, which it is, p-value is 2 times the VFD. So 2 times VFT. So our p-value will be 2 times 0.1587. 2 times 0.1587. I get 0.3174. Okay. Alpha is 1%, 0.01. So our conclusion, if p-value is less than alpha, well, it's definitely not less than. So if p-value is greater than alpha, accept H naught. So our conclusion is, we'll accept H naught, and that means you'll reject H1. And our claim matches H1, so whatever we say about H1 is what we say about our claim. We rejected H1, which means we'll reject our claim. Let's look at our fourth example. Okay, according to Chicago Tribune in 1990, 29% of teenagers believe in witchcraft. If a sample of 500 show that 80 believe in witchcraft, Tesla claims the percentage is lower nowadays at alpha is equal to 5%. So lower than 29%. These are P's. Lower than, that implies a less than, which should go here. This will be greater than or equal to. And remember, this is the left tail. Lower than matches H1. So, let's see. Done step 2 and step 3. Okay, step 4. We'll find our test statistic. And Z naught is equal to P hat minus P naught over square root of P naught times 1 minus P naught divided by N. P hat is again X over N, so we got 80 over 500 minus P naught, which is 0.29 over, I'm out of space, square root of 0.29 times 1 minus 0.29 divided by N, which was 500. So we'll press or put a beginning parentheses. We want parentheses on top. 80 divided by 500 minus 0.29. Close parentheses divided by second x squared 0.29 times beginning parentheses 1 minus 0.29. Close parentheses divided by N, which was 500. Kind of a big value. Negative 6.41. Assuming I typed everything in correctly. 80 divided by 500 minus 0.29. Yeah, it looks right. Okay. Well, the value from the table won't be on there, but we'll get close as we can get. Negative 6.41. Our very smallest one is the 0.0002. Now this is a left tail. So left tail, it says your p-value is the value from the table. So that's our p-value. Now for a conclusion. That's obviously less than alpha, but let's see. P-value is less than alpha? Yeah. reject H naught. So reject H naught, which means we'll accept H1. These are opposites of each other. Now our claim matches H1, so whatever we say about H1 is what we say about our claim. We accepted H1, so that means we'll accept our claim. And that's the end of that section. So let me stop the recorders here.